Hello, today we're going to show you how the 770 geometric system works. We want to show you a quick run through on how we would do flatness. This is one of the main components. The 770 is a full shaft alignment system. This is the M detector that we're using for the geometric right now. It also has an S unit, but we're only going to use the one for now. Okay, I'd like to point out the LED. I've actually got 87% battery life, and you can see the inclinometer that's in the head. As I turn the unit, you can see I'm roughly 45 degrees. This is my on-off button. I've got a target door that I can open or close. Helps me set up. Simple. Another major component is this. It's called an XT22 sweep laser. The beam is on, and you can see it actually in my hand. I can actually also move the beam 90 degrees, so you can see this is 90 degrees to the sweep. But I'll go back because I want to sweep today. This is my control. This is my digital level inclinometers. As you can see, they're off a little bit. These are my controls for the vertical plane. I want to adjust this. This is my locking ring. This is my coarse adjustment and my fine adjustment. If you look here, I've actually got 3 mils per inch, and I'm bringing it down till I can get roughed in. That is half a mil. This is for the x-axis along its length. I have another over here. It's the vertical for the y-axis, locking ring, close adjustment and fine adjustment. This control here allows me to move the beam fine adjustment in the horizontal plane, which helps me set up. I use it as part of the calibration. I'm going to start the program. This is my display unit. I'm going to start the program, and I'm going to go into values. I can continue with what I've been doing, or I can start new. I'm starting new. I'm going to place my detector a meter away from where I have my laser set up. I'm going to connect both. They're both connected. So I look at the measurement. Okay. This is a digital display that I can also see in my report. And this is the beam. I am sweeping the beam over to the detector, and I'm putting it into the center of the screen. I will now open. Now you can see a lifetime reading. This is the level. This is the lifetime reading. In the vertical plane, currently I've got 38.2 mils, which is the same as now. And in the horizontal, I've got 4. I will just adjust that 4 by turning this screw. It's better if I get it. I like to be able to be in the middle of the plane. From this point, if I wanted to go and check the calibration of these digital levels, I can tap the level. It gives me zoom, resolution, calibration, or device settings. I'm going to tap the calibration. This is basically a tutorial, and it's telling me that I have to place the level transmitter on a flat, clean, stable surface, which is this. And to start it, I have to tap the green button. It's prompting me to mark where I've placed the laser transmitter, the XT22, which I have done. It says mark the base of the laser transmitter and tap. So now it tells me to level the transmitter according to both electronic levels by using the tilt screws. These are my 2 tilt screws. I've got 0.6. Going the wrong way. 4, 3. Like that. I've leveled it. I will now tap. Place the detector at a distance by moving the detector. Do not touch the laser transmitter and tap. I've taken the first reading. It now prompts me to index, rotate the laser transmitter 180 degrees and then sweep the beam backwards until I put it into the center. I'm roughly there. Okay, next I rotate it and I tap. Okay, I have to re-level the transmitter using the tilt screws. And now tap green to continue. I have to center the beam on the target. It says 52. This is very fine adjustment. Okay, be happy with that. And now press green to continue. Now it's asking me to adjust the vertical plane. However, it's 0, so I don't have to. So I'm actually just going to press the green and it's calibrating the system. Now then, I've just done the X direction. It's the same program to go and do the Y direction. And that's, you just follow what I've just done there. There are many ways that I can mount this. For instance, there are 3 magnetic feet with retaining plates that I have to slide off. But I'm going to use this adapter plate that I can mount onto the base. Now I'm going to be able to measure this base using level as the reference plane. I begin, I'm on a solid mount, I've got 2 magnetic brackets, and I know this is a very nice solid mount. I will begin by leveling both planes. That would be the X and the Y. Now, I mount my detector. I sweep the beam in. I can actually see that it's high, that it's low. I'm going to start my values program. Start new. I'm connected to both units. I'm going to go and see a lifetime measurement. You can see the dot. I'm at 9 mils, 9,000. I'm going to just finally adjust so that I can bring it into the center. I'm moving the beam into the center of the detector surface. As you can see, it's not affecting the vertical at all. I just like to get it closer to the middle. That's close enough. Theoretically, I can move around to any point on the base, and I can see where that is in relation to level. I can zero the reference point. It's gone to 0. I can move to another point. Sweep the beam in. I am 1.5 mils higher than this point. I'm going to just take 4 measurements on this base for simplicity. I'll begin here. One. Two. 3, and the last. So now I take the 4th point. Now, I've got all that I need. I can actually go and see it. That's a table. If I want to see it as a graph, there it is as a graph. It's given me lots of options. But I may not be able to use level as the reference point. What I can do is create my own plane. I will just remove that. The way I can do that is I put my detector close. I electronically zero it. And move it out to the further point. And I adjust. It's actually very close. I adjust this to 0. Physically. I come back. I zero it again. I've got 2 reference points. I now go to the 3rd. And I can see that it's off. I'm now adjusting this. It's 6 mils. I'm bringing it down. 0. I have now created a reference point. 1, 2, 3. And now I can sweep the whole laser beam across the table and get a lifetime measurement of where it is. That is 6 mils high, 6.5 mils high. So it's lifetime. I can make corrections. We've created a level plane using the inclinometers, digital inclinometers. And then we created a physical plane by bucking in the laser beam to 3 reference points, 0, 0, and 0 at the far end. Now we can do a similar thing just using a basic flatness program. I can continue an old one, or I can start a new one, which I am doing. I can take up to 16 points along 2 rails, but for this, that'll be overkill, so I'm just going to go and do something simple, and I'm going to leave it at 4. It asks me for some dimensions. I can measure A to B from center to center, which is 16 inches, and input that information. Now I can measure down the length. From center to center, I have 24 inches. And I can close the window. I can now mount my laser beam detector at the first point. I place my detector in the center. Move to the measurement screen. I can see a lifetime reading. I'm going to record that lifetime reading. It prompts me to go to the furthest point. I put my beam in. I can see it. I'd like to get it a little bit closer to the center. And I'm going to record the value. It's my 3rd point. Now, that's my last point. Now, I can see those results. That's the raw values, as you see. It's very close. I have one high spot. That's a B2 right there. It's 9.4. This is the other high spot. It's 5 thou. On this side, I've got almost flat. It's flat. I can zero different points. I can pick all the negatives. I can pick all the positives. But I don't have much data to show you right now. In the real world, maybe what I would do is I would measure each corner of each foot. Obviously, after taking a lot more data, what I could actually go and do is show a live a report. And I can press that. And you can see it as a report.